Okay, hello. Can see a bunch of you out there. At least I hope that you're out there for the live stream because it's always nice to have some people to interact with. Hello, Edcast. Nice to see you. Happy Monday to you as well. Um, so I got through the labs from last week. You guys are just kind of settling into doing rock solid work, so that's great. And there's nothing for me to say there, so it's a good thing. Hello, Isno. Nice to see you. Uh, so anyway, those unit tested labs, unfortunately, you all know what everybody else's work generally look like. So once we get a round of projects in, then I'll do a few demos after I've got those evaluated, and then you'll kind of get to see the products of some of your classmates' work. First project is due on Sunday this week. So hopefully you've started, and if you haven't started, hopefully you've left yourself ample time to do it. The projects are much bigger chunks of points because we generally work on them over a matter of 3 or 4 weeks at a time. So anyway, please don't forget, first project due on Sunday with all of the normal stuff on top of that. So that's where we're at. The labs look great. I'm glad everyone seems to just be rocking with the lab work. There were no patterns even there to sort of say, oh, I saw this kind of thing going on. Everyone just did nice work. So Ember Wolf asked in chat if we'll discuss the project. I can bring it up and look at it and see if there's any questions in chat, but it's pretty straightforward. It's kind of a first semester kind of project, really. So you can do fancier things with it if you like, but we'll look at least the requirements and see if any questions come up with that. So let's do that now, and we'll get it out of the way. You can get to the project. It will be on this week's reminders, but it's also on the course homepage. So, and there's a good chance I'd say that it's in your to-do list at this point as well. So let's just see if there's anything unusual in here. So the requirements, documentation in the style that I always do, which is the name of the project, the programmer's name, and the date. The date, I don't care about it being precise. It's for some people the date that they finished it. For some people the date they started it. I don't really care about that as long as it's a date that kind of shows roughly the time frame that the code was worked in. Good source code formatting and naming. I never use bad source code formatting style in my samples or on the stream. So if you're in doubt about what the source code should look at, you can just look back through my samples, which are always formatted in a fairly standard way. There's also, you can just Google that if you're still searching for your own style, but your formatting should be neat. It should be consistent. Your naming of functions and variables should be consistent and neat. Because we don't want to exit a second semester programming class with slop on the screen. Your program's output should look good. This is things like spelling, spacing, that if you're prompting for inputs, hopefully that makes sense or it's obvious to your user what should be done. Those kinds of things that make for a polished product. So you want a polished product from the source code all the way to the program's output. And then the requirement. So there is a requirement that you use a struct or a class, but there's no requirement about how you use the struct or the class. You can use more than one struct or a class. You can use a struct and a class or some combination of those things. But somewhere in there, I want to make sure that you've forced yourself to practice on the syntax of a struct or a class in C++. I have given you in the labs some hints about that. So we had a struct item, in fact, a couple weeks ago. And I know last week was a bank account, but it was associated with managing money. So I meant to sort of seed you with a few ideas in code. A minimum of 5 products. You can have more. Any more than 5, I wouldn't bother. but you could. A menu that displays the options so that your user, me, knows what to do. Your menu should allow your user to quit or to select items, but they should not be allowed to select and attempt to purchase items that are sold out. Collects payment. The payment system, to me, can work in one of two ways. There's screenshots at the bottom. So my payment system is it's more like a convenience store where they get a basket full of items and then they pay for everything all together at once at the end. But you are allowed to implement a system where it's more like a vending machine where they select an item, pay for the item, get their change, and move on to the next item. Although there is a requirement about histories in there. Change should be shown when it's appropriate. When they buy an item, it should decrement the quantity. I only allow my user to buy one item at a time. So if they want 2 waters, they have to select water from the menu twice to get it. You could, if you wanted to, say, select how many waters that you want, as long as that doesn't exceed the number that's in stock. And no matter how you made your payment system work, there is a requirement that you keep track of all the activities that go on while the user is running the program. So at the end, you get more or less a receipt or a record of the vending machine's activities, which should be the total number of items that have been purchased and the total amount of money that was taken in. And I have screenshots of all of that from my own implementation. So you can see my main menu. I can blow it up. Are you seeing what I see? Yeah. So you can see my main menu. It's friendly for your evaluator, the person testing your code, which would also be you, I hope, to set 1 or 2 of your stock items pretty low so that they can be sold out quickly. So if you have everything, there's 100, there's 100, there's 100, there's 100, that's kind of mean to your evaluator. It also makes your life more difficult because you want to be able to quickly test whether or not things can be sold out. So in my implementation, I kind of set the stock levels at different values so that I could kind of test the decrementing, test to detect when things are sold out. So you notice that my machine starts with only 1 candy in stock as an example. I guess my machine, this version of the machine that I put pictures of, I allowed them to buy up to as many as there are. Oh, that's fancy. But you can just have them buy 1 when they select that item. They can also, in this implementation, say 0, meaning I changed my mind. And then in my implementation, it's very clear when an item is sold out. But if they should select that item, it should not let them, it shouldn't decrement. It should just get a message saying you can't buy that anymore. It's sold out. And then I have the payment sequence. So I was showing here that if they don't pay enough, I ask for more, I ask for more, I ask for more until I get enough, and then I emit some change. And then finally, a receipt or a record that shows everything they bought, what the total they paid, and I actually added the change due there. So anyway, the screenshots are there so you can see an example sequence without the source code, of course. But any other questions you can ask during the live stream today, you can ask on Canvas or in Piazza or at office hours if you have additional questions about your implementation. But you can do just absolutely the most straightforward thing while addressing the requirements, and that's fine. There's no contest to have the coolest one, but if you have a cool one, I'll show people because that's always fun for everybody to see. Okay, so there's the project. So now I won't get to the end and think that I've run myself out of time. Okay, so we have 2 things for this week. Handling command line arguments, and I'll show you how to do that in Replit also, and then also how to handle inputs from files. So let's first walk through the module, and then I'll just go to Replit like I've been doing and run up some examples. So we're on lab 6. Lab 6 will not be unit tested this week. It will be interactively tested, meaning that I will run your lab 6 in a variety of ways. I'll show you examples of that to evaluate it. So we're going to add in the ability to handle command line arguments, and then finally the ability to open a file, read its contents, process its contents into our data structures, and then display the results. File reading in C++ is pretty easy, so this is not too big a deal, really. And then I do have my sort of preferred tricks for doing this. Okay, the lab, so let me pop open lab 6 and have it as a reference. But I'll do something similar to lab 6 without its assistance. And then I changed the lab just this morning. I decided that my screenshots were just impossible to read because compressing them to upload them just kind of lost the important details. So I just changed it to text to kind of show you what you should do before you submit your lab. And it's also what I'm going to do when I evaluate your lab. I will do as much as these things as I am able to do in your REPL. We have a poll this week, so that's meant to give you a break. And also to get me some feedback about where I might want to go back and revisit prior topics. So it's just a vote in it kind of thing, and Piazza keeps track of who participated, so I can download a spreadsheet and I'll know who participated in the poll. But it's also meant to be a break from research. All right, and then finally, the big thing, which is the first project is due on Sunday at the same time as all the other stuff is due. But we've had since August 23rd kind of to work on the first project, and certainly at least since week 3 when we talked about structs, the whole project could be done by then. Okay, so let me address a couple of questions in chat. Yeah, so Magenta asks about the 2 files of input. Yeah, good point. I'm going to change that, Magenta. I don't think anyone's turned this in yet. So let's do both. Thank you for pointing that out. I guess I'll take this. Yeah. For adding to a REPL. Okay. Thank you, Magenta. I appreciate that. Having my back. So I do mean the fruits and the drinks files are just there for you to test your code against, but I will end up testing it against them. So thank you for pointing that out. You do want them both, which is a way to confirm that your code is working against 2 different formatted in the same way, but 2 different input files is a good way to confirm that your code is actually doing its processing job correctly. I think I don't have anybody who got that in yet, so thank you for pointing that out. Okay, so command line arguments and file inputs. So let me make sure you can still see what I see. Okay. This is week 6. Is this week 6? Yeah, it is week 6. Wow. Okay, so we're going to make some changes in here so that command line arguments will work. This is going to be new to a lot of you. And some of it looks a little bit funny, but the meaning of it is not that big a deal. So let me just show you what the code looks like first. So we are changing the way we set up main so that our program can actually accept arguments from the command line. Um, and so I'm just going to sort of whip up a quick thing here. I'm just going to do the big global namespace thing so that I save the screen real estate. Okay, so what are these two things for? argc and argv. So argc is an integer. The C is there because it means a count of the number of arguments that have been supplied to the program. argv, well, the V probably means vector, but it's easier, I think, to think of argv as an array of those arguments. So we're just going to write some code to display this information and then try to gain some understanding of what it is and where it's coming from. So I'm just going to print them both out. I know the char star star is off-putting. Another way to write this is char star. Wait, that's Java. Oh, darn it. That's F9, F10, F11. That's probably Java style. Is this C++ style? Another way to write this argv thing is like this. But I just think it looks a little bit cleaner this way. So what is this thing? It's basically a string array is all it is. So char star star is the old, in the C language that C++ at one point at least was kind of evolved from. In the old C language, there was no such thing as a string. There was character arrays, which were these things. So in C++, we use the string where the C language would have used the char star. Unfortunately, we can't just put string here because C++ won't recognize it, I don't think. Okay, so you need to learn, for starters, to think of a char star as simply a string. This whole setup derives from the old C language, which is why it looks this way. Okay, so there's that. So we're talking about an array of strings. What about this other star? This other star means dynamic. So we are talking about a dynamic array of strings. Dynamic array. A dynamic array of strings. Why is it dynamic? Because when the user runs the program and supplies these arguments, the number of arguments is unknown. So the space to store those arguments in an array has to be allocated by the system dynamically on the fly. So this number of arguments and the array that contains the arguments, those happen at the moment the program is run. The arguments are going to be processed into the program as strings. So anyway, don't let the char star star put you off. That is really just sort of some cruft from the old C language that means a dynamic array of strings. But all this really means is this is going to contain all the arguments that are supplied when the program is launched. This is going to contain a count of how many arguments there are. So let's print them out and see how that works. So see out number of arguments supplied, argc, and then I'll have to write a loop. Using that counter, all right, so the loop. So the first one is just printing out that counter. The second one is using that counter and an I variable to loop through this array, argv, and print out each element of it. And then I'm just reusing the I to show the indexes of all the arguments in the array. So I'm going to run it. Okay, so the very act of running the program is supplying an argument to our code. There was one argument supplied. It was /main. So that's argc is 1. And the first argument that was collected into that array of the things that were supplied on the command line was /main. So now we're going to go down here to this area and we're going to run it some more. So /main hello. Now I supplied 2 arguments. The first argument, the one at index 0 of that argv array, is the program name itself. The second argument, which is the element at index 1 of that string array, is that word hello. And then I can do 99 void 3.14 true negative 15. So, and just so you can see how the arguments, the command line arguments work. So when we launch the program, the system collects all the arguments from the command line, it counts them, and it puts them in an array. So let's see if there were 7. /main is 1, hello is 2, 99 is 3, void is 4, 3.14 is 5, true is 6, negative 15 is 7. So that is true that the count argc should be 7. And then as I loop through that argv array, printing each of them, I am seeing all of those elements that have been collected separately into that dynamic string array. The reason why it's dynamic is because the number of arguments can change for each run of the program. Okay, so hopefully that's enough to just explain what these things are, and then we can explain how do we use them. So that's the what they are part. And then we'll do the how do we use them part. So I'm going to comment this stuff out. But I'll leave it there for the code sample so you can. So we can use this to sometimes require an input, or in other times to override default behaviors or something like that. So let's just say, for example, let me get a string in here. So let's just say, for example, we have a string username equals, well, I'll do it this way. I don't know. Jane. So one way that we can use command line arguments, so let's just say this is the default username, Jane. We can use the command line arguments, understanding that there's always one, which is the name of the program itself. So we can say if the count is 2, if the count is 2, that means that the user supplied us on the command line, not only with the program name, but also something else. So if the count is 2, we can actually override our username by going into that argv array and grabbing that second item that the counter told us was there. So this is one way we can use the command line arguments. We could have some default data inside the program. And then if we detect that the user has supplied that extra piece of information, that second or more arguments, if they supplied that, then we can override the default username with the one supplied at the command line. So when we change the code in Replit, we have to click run at least to compile it. But it will also run it with just that argc being 1, in which case it just says hello to Jane. But now I can have it say hello to me. I can override that default piece of data. And you'll notice that in this case, I'm just ignoring, if they give me not precisely 2, then I'm just going to drop back to the default. So I could do something in this case. So I could say, for example, if argc is greater than 1, meaning there's at least 2, well, I'll just grab the second one and ignore the rest. So I could do it this way. All right, so now I can type /main. That's greater than 1. I can also put some other stuff on there, and the program doesn't care. It's just going to grab that second argument, argv1, and ignore the rest. So we can do that kind of thing. We could also do something like this instead. We could process all of those arguments. If we get more than 1. And in this case, this username doesn't even actually matter anymore. I'll leave it. So we could say if I get 2 or more pieces of data, I have to click it to run, which will run it with no arguments, but then I'll run it. So there's me, and then I could run it again with another person, and this number 99, and 14, and it'll say hello to all that stuff. So just kind of exposing you to the different applications of these command line arguments. Another thing I can do, I guess I'll comment that out. Another thing I can do is I can require that the user provide specific argument or arguments. So I could do this as an example. I could say if argc, if they only just run the program, then I could say, hey, to use this program, you type the name of the program, which is the argv0 always, the name of the program, followed by a name or names. Otherwise, I'll assume that they did provide 2 or more, and then I'll just say hello to all of them. So here's another way we can use command line arguments is we can use it to require that the user give us specific amounts of information. So in this case, if they only just ran the program, then I'm going to spit out a usage message at them. Otherwise, I'm just going to cycle through all of their arguments. Start this at 1. So that we don't say hello main, we just say hello and the rest of their stuff. So there's the usage because I ran it with no arguments. If I run it with 1 argument, it's happy to say hello. I can run it with 2 arguments and it'll say hello. Okay, hopefully that sort of additional option or reason why we might use this to require certain amounts of information. We can also do something like this. So in that case, I just said I need 2 or more. We can say I need exactly 2. So sometimes we need the name of the program and then we need exactly 1 more piece of information. So we might say, for example, and I'll just use argv to print out the program name as they typed it. So the name of the program followed by, let's say, a file name. Hint, hint, this is something that you want this week. So there's another way we can use command line arguments is to specify exactly how much and what kind of information that we want. That doesn't mean the user is going to give it to us necessarily, but we can at least tighten up the user and get them closer to what we need. So if they don't give me exactly 2 arguments, then they're going to get a message saying, I need exactly 2, one of them being the name of the program followed by a file name. Now, if I get exactly 2, then I will print a message saying I'm about to try to open a file for you. So let's click run to compile it. We get the usage message here because we didn't provide the second argument. So if we do, then the program recognizes, okay, that's what I need. Boy.txt may not be openable, it may not even exist, but at least I've gotten this far with the command line arguments part. And then hopefully you can appreciate, like, this program could be written to open any file and do something with it. And all the user has to do, they don't have to compile the program, they just have to type the name of the file they want to operate on the command line. So I could do jane.txt. Now, if I put more than that number of files, right now they're going to get the usage message because I need exactly 2, not less than 2, not more than 2, exactly 2. Okay, so that is command line arguments. This is the way that we will use it this week. Is we are looking for exactly 2 arguments. And if we don't get exactly 2, we're going to print out a message telling the user what we want them to do when they use our program. This is common, by the way, to have a usage message. Like, this is how you're supposed to use this, dummy. It's basically what it says. The name of the program and one and only one file name. Okay, so that's the one that we're going to use this week. I'm going to comment it out for now so we can do other things. In fact, let me comment this main out, and I'll put another main above it. Someone in chats reported that the video is a tad blurry. I wish there's anything I could do about that, but there's nothing I can do about it. I don't have any other network activities going on, so I wish I could do something about that. But these are all samples that'll be loaded anyway, so yeah, I wish there was something I could do about that. Hopefully that resolves itself, Magenta, and it comes back to being better. Okay, so I pushed all that main down, and now let's work the other problem. I left the arguments here for now, which I'm going to ignore until I get back to the point where I put all the parts together. So the other thing we're going to talk about is reading files. So to read files in C++, you need to include the fstream library. And now I am going to change my using directives to be more specific. So let's see, standard cout, standard inline, and then let's add, so fstream is the library. That means file streams. These files can be input streams, meaning you're reading data into your program, or output streams, meaning you are sending data out from your program to a file. So we're going to use, in this case, the input file stream, whose job it is to allow us to open and read in the contents of a file. I also need, in case I end up using that, which I probably will. Okay, so now the input file stream problem. So I don't have any files other than the source code here, but I'm going to go ahead and just pretend like I have a file. So the way you open a file, pardon me, is pretty easy. You use ifstream, and then you give the file a name. I'm just going to call it file. So file is going to be an input file stream, meaning that file is meant to receive data input into the program having been read from a file. And then you offer a name, like a test.txt. C++ is going to assume that test.txt is in the same folder as main.cpp, the way this is written, which it's not, but that's good because then we can test to see what happens when the file is non-existent or for some reason can't be opened and read. So this one line will attempt to open this file and ready itself to read input from it. But to get you in the right habits, we're going to check to make sure that that file was actually opened. So the first thing that you will do is check to see if you failed to open the file. And there's a whole bunch of ways to do this, but this is a quick test to see if I failed to get connected to that file for input. This fail could happen because the file doesn't exist, which is the case right now. It could fail because it's a read-only file. It could fail for some kind of hardware issue. There's a variety of reasons why you might fail to get connected to the file. So whenever you do this line of code to attempt to open the file, the very next thing you do is check to see if you failed or succeeded. You can do this the other way around, by the way. You can also check to see if you're in a good state, but I usually check for the fail first. And then I say failed to open test.txt, which is what should happen now. Okay, and it did fail to open, and the reason it failed to open is because it doesn't exist. So let's go create it. Test.txt. I'll just leave it empty for now. And I just want to see if it doesn't fail. So now we'll add the else part. So we're either going to fail or we're going to succeed to get that file open and it be ready to read from it. Okay, so we got it open and got it prepared to read from. It just doesn't have anything in it. So let's put something in it. So I'm just going to type the word hello in it and leave it at that. Okay, so how do we do this part? So the way we do this part, at least the way I'm going to teach you to do it, because I think it's repeatable and it's kind of one of the easier ways to handle this problem. Well, what we're going to do is we're going to loop the file and read all of its contents one line at a time. The way we're going to do that is we're going to say while I need a string for this. And then we sort of engage some behavior that is not entirely obvious and seems like a little bit of magic. But if we're in this else part, then we manage to open the file and we can now read from it. If we couldn't open it or we can't read from it, then the attempt will fail. So now we're in the attempt to get it open and it's ready for me to read from it has not failed. In other words, it succeeded. So how do I do that? Well, I need a variable that I can use to grab and temporarily store each line from the file. This get line, the way it works is it reads the current line and then it automatically advances to the next line and waits for you to do another get line on it. So the effect of this while loop will be get a line, advance to the next line, get a line, advance to the next line, get a line, advance to the next line. And it will automatically do that until there are no more lines to be got. At least we hope that's what it will do. So I'm going to get one line from the file. I'm going to store it into my next line variable. So each line that comes out will be the next line that I got, and I will just print them for now. So let's run it and see if it works. All right, so there's hello having been read from the file. Let's add a few more lines and see if it automatically advances through them. Put some spaces in there. And we'll even see what happens if I put a blank line at the bottom. So we don't have to, we're just going to click run. Although technically we don't have to click run. We can do /main, but because the code didn't change, we don't need to recompile it, just the input file changed. So I could technically go to the console and just do /main. There are my lines, and notice that on that last blank line, it didn't read it in. So it realized that was a line with no contents on it and stopped. And I can just keep adding. So I can put that in the file. Repl.it, by the way, automatically saves the file. There's no saving operation. Repl.it's kind of constantly just saving as the file changes. But I'll go down here to the console so I don't have to wait for the compiling stage, since I don't have to compile. Run it again, and there's my nice weather we are having. All right, so now I can read in all of the contents of this file. Just with that. Okay, so now we're ready to add another thing. I'm going to comment this line. I'm tired of looking at that. So let's change the file and try to do something more interesting with these lines. So let's change this file, and let's say, I don't want to do something exactly the same. So, if you were in Linux, I'll just use the Linux one. I'll make a little shopping list with an item, a category, and an amount. We don't need that many. I got most of what you need. Yeah, let's leave it at that. Okay, so this is the kind of scenario I want you to learn how to deal with this week. What if someone has created a file that has actual data in it? How do I get that data from the file and actually process it into my program? And if we look at the incoming data, every line is formatted the same way in a respect. The first element of the line is the name of an item, and then there's a comma that separates the first element of the line from the second element. The second one is sort of a category or a section of the store, you could say, and then another comma, and then a quantity. And every line is like that. The name of an item, the category, and a quantity. The name of an item, the category, and the quantity. So this is the situation that we want to learn how to deal with this week. How do I take this data from a file and actually get it loaded up into memory, like into structs or arrays or something, so that it could then be manipulated by the computer. So that's what we're about to add to this. First thing though is I'm just going to run the program. I still didn't change the code, so I can just run it, and I'm getting those 3 lines. So Magenta makes a point about we're going to have to deal with the commas somehow, and that's correct. And I have a way that I like to do that, and I'll show you that. So somehow, so we can get the lines, the program already does that. The problem is, once we have the line, how do we break it apart into its component pieces so that we can use those component pieces as variables in software? So this part of the problem I will call parsing, which is pretty much what it is. So we're going to parse the file data. And by that, I mean we're going to break it apart, break it up into its component parts, and then load them into variables in our code. So I'm going to keep my next line, and I'm going to add some variables here. So I'm going to have an item name. I'm going to have an item category, and then I will have an integer that is an item quantity. Oops. I'm going to keep next line in here because I'm still using that to just grab the whole line. Once I've grabbed the whole line, then the problem becomes how do I break it into pieces? So this is the way I like to teach people how to do it. I think it's very adaptable to different situations once you've learned the basic approach. So we're going to use more of these stream things, but we're going to go back to string streams and show ourselves a way to use string streams for parsing data. So we need a iString stream for this. So the iString stream is cool because we can actually load it with data and then use the stream to bust the data apart. This is how it's going to look. So we'll make an iString stream. We will call it our parser. And we're going to load it up with that whole line from the file. Okay, wait, that feels funny. I'm not going to worry about it. Hopefully that's not bad. Okay, so we have an iString stream. I have named it my parser. Well, let me look at fstream. Something feels wrong about that. Oh, well, I'll just leave it. I don't like the way that it's coloring up kind of orange, but okay. So we have this thing called parser. We have populated it with next line. So you have to kind of picture what's going on here. We have this thing called parser, and inside of it is one of these lines at a time. So the parser will be built around that line, and then the loop will repeat, and then it will be built around that line, and then it will be built around this line. So we can use the parser to bust these lines into pieces. And it's quite slick the way that this works, at least in my opinion. So remember that the parser is going to look something like this. It's going to have a name, it's going to have a category, and it's going to have a quantity in it. And we're going to use the parser to pull off the name first, and then the category, and then the quantity in that order. So what does that look like? So there's the first step. We're going to use the getLine routine again, but in a slightly different way because we're using it with the parser, not the file. But what we're doing is we're actually telling this getLine operation to go into the parser, read everything up to the next comma, and store all that data as the item's name. And it should be true that the item's name is the first field. So the first get line we do should everything up to the first comma be the item's name. And let's print it and see if we're getting the item names out. So I should have commented. Let's comment this out so we're not. No, let's leave it. Let's leave it. It's okay. So we can see here, there's the next line. And then the parser has grabbed just the name, everything up to the first comma. And then the line after that, and the parser has grabbed everything up to the first comma. And then the next line after that, and then the parser has grabbed the first thing up to the comma. And we can keep doing that. So just like in the file, where get line advances to the whole next line, in the parser, the get line will advance to whatever comes after that next comma. So this parser will automatically be sitting on the next character after the comma. So we're going to do another get line on it. Knowing the parser is advanced just to one past that last comma, this will be the item category. And we'll stop at the next comma after that. And we'll print out item category. So we have to picture again, if we load up the parser with the whole line, and then we get everything up to the first comma, well, that should be the name. Everything up to the second comma should be the category, and then we're not dealing with the quantity just yet. And then we can see when we get apples, then the first thing we got was the name, and then the parser got the category. The second line, the parser got the name and then the category, and then the third line, the parser got the name and then the category. So all good so far. And this is what Magenta was talking about, where we're using the comma, because we know the comma is what separates one part of the incoming data from another part of the incoming data. Let's get the last thing. This one's going to have an error in it. So technically, this last parser activity, since it runs to the end of the line, doesn't need to be told to stop at the next comma. It will just run off until the end of the line if you don't tell it to stop somewhere else. If you tell it to stop at a comma and it gets to the end of the data, that's okay too. But since we know that the quantity is the end of it all, we don't really need to say stop at the next comma because we already know there isn't one. The item stops at a comma, the category stops at a comma, but the quantity, just everything to the end should be the quantity. And then we'll print out the quantity. This one's going to have an error. Okay, so it's a wall of errors, which is kind of a pain. But let's see if we can read a little bit and understand. So it's complaining about line 31 when we try to parse the item quantity, which I'll remind you is an integer. So the strings worked fine. The integer is yielding an error. If we look around, we'll see in this bit of error output, against int, it's complaining. Against int, it's complaining. And then we get some more errors. So this is a hard error to understand, but these first two outputs of the stack are complaining about int, but I also just noticed that the strings worked okay, but not the integer. So let's just see if I change it to be a string. Does it work again? Okay, so all's good with the string. But what if I wanted it to be an integer? Because in my program, I might want to increase or decrease the quantity, which I can't do if it's a string. So I need it to be an integer. So what do I do if I need this data to be an integer, but it appears that it will only be happy with a string? So here's the way that I would do that. I'm going to give myself a string and just call it temp. And then I'm going to parse this into temp. And then I'm going to use a function to convert this string into the integer that I need it to be. And I think it's as simple as my item quantity is simply equal to string to integer this temp. So if your input data has things that aren't strings in them, everything's a string unless you force it back out of being a string. So this function, that means string to integer. We'll go look at it at c++.com, which I think will take a string and return it as an integer. Now I have to be careful about this because it will blow up if what I'm trying to make an integer can't be one. Let's run it though and see if it works. Okay, so everybody's happy in my code with this string to integer thing. Let's go look at C++. ++.com. And let's look at STOI. It's a little bit scary looking, but basically we can see here that it returns an integer. It's called string to integer, and the only required argument is a string. So if you give it a string, it returns an integer. You can also fiddle around with the number base. We want decimals, so we don't care about that. And you can fiddle around with skipping over parts of the integer. But anyway, for us, we just want to give it a string. We get an integer out. So where is my REPL? Okay, so now I have actually successfully parsed all of the data from the file. Now, why would I do such a thing? Well, it might be that I've created a struct up here. Where I have string name, string category, int quantity, and then I can, instead of printing these things out, well, I'll print them out, but I can turn them into an item. So item, and I'm going to build it in this way. So that you've seen this way. Hopefully it works. And then we'll kind of improve on this. But the whole point of this is that you sometimes have the data that you need stored in a file, which introduces problems. I got to open the file. I got to process all the lines of the file. Each separate line of the file contains possibly its own piece, its own entry in this database, basically. So I have to get the line. Now I have to parse the entry into its component pieces. And since everything coming in is as a string, the things I need to be not strings have to be converted into whatever the types are that I need, such as integer. And the whole purpose of going through all that is so that I now have something in my program that I can now do programming work on. So in theory, I'm going to move these and print them off the item instead. And then I'll explain to you what I did with the struct. So let's use the item just to confirm that the item has the correct name, category, and quantity on it. I'm also going to get rid of... No, you know what? Let's put them on the same line. And we'll just make them look different from what the file looked like. So we know for sure that it is what we think it is. Is that all in one line? I think so. So the ones with the dashes and the spaces, that's the one that's been processed into the computer and is now in a struct with the appropriate data types. except for I screwed up somewhere. Right here. And then you can see the raw data from the file and then the process data from the program. The raw data from the file, the process data from the program. And I should be able now to go add things. So time for lunch, so ham sandwich. And since the commas are what divide the entries and the elements, I can use spaces. But I can add these things now. Snack. I have 2 of those. Call that snack also. But anyway, I can now add to it and the program will just, and I don't even have to recompile, I'll just rerun the program. And the program will automatically, as long as every line is formatted correctly, then the program can process that data in. No. So Magenta asks, is the raw data quantity still a string? Not anymore, it's not. So because I did this. So I used the parser to get a temporary string that I know to be the quantity part, and then I convert the temporary string that's the quantity into the integer that's the quantity. So no, the quantity is now fully converted into an integer inside of the computer. And then I even populated the struct with those 3 elements, and they're all typed correctly as well. So one thing I didn't tell you, the way I am building the struct. So you can initialize a struct if you provide it with all of its fields in the same order left to right as they appear top to bottom. So left to right, name, category, quantity should match, must match name, category, quantity, top to bottom in the struct definition. So this is a quick way to populate a struct as you are declaring it. So the raw data in the file, so Magenta and in chat asks, is the raw data in the file still a string? And yes, the answer is yes. The raw data from the file is still a string all the way up through the point where I've parsed it, broken it apart, and then I have to do this extra step where I convert the raw data, which is still a string, into an integer, which is what I need inside of my program. So yeah, I think I said it correctly for you this time, Magenta. Now the raw data is a string. When it comes from the file, it's a string when it is parsed from that line, and then it will remain a string. And in fact, temp is still a string. It's just I use this function which yields that string converted into an integer. And then I can use that to initialize my item. So that's the whole thing. Which means I probably will get done early. I'll put this. Oh, no. We still have to do the arguments part. So let's fix all this and get the arguments part. So I'm going to leave all my file processing, and I'm going to comment out this next line, which is just testing output. But now what I want to do is I don't want to be hard-coded to this file specifically. I want to be able to use different files. So I want to be able to put in different files, understanding that every file has to be formatted the same way. So there's my test file. Now I might make a dinner file. And I'll format it the same way. So we'll have I don't know, chicken, which is the meat for the dinner, and that will be have 1 piece of chicken, and then we'll have peas, which is the vegetable for the dinner, and I'll have like 100 of them, and then we'll have potatoes, which we'll call the starch component. We'll have one of them. We'll just have I don't know, I'm not a wine drinker, but I wanted to put this, I thought it'd be more fun to look at. The red wine, which is the beverage part. Uh-oh. I believe that's wrong, isn't it? Some of you will know better than me. I think it's supposed to be like the chicken meat goes with white wine. I don't know. We'll have a bottle of that. Let's make some of these different so that they don't all look the same. Yeah, that seems okay. So what I want the ability to do now is I want to be able to process any file of data that matches this same format. So any file of data that should match this same format of an item name, a category, and a quantity with commas in between. So I made this dinner file, and I would like my program to be able to do that, but right now test is hard-coded in. So I could hard-code in dinner, and then dinner. But what if I still want to go back to my old test file? Or what if I want to make a lunch.txt file or a breakfast.txt file and have this program kind of just adapt to the different files as long as they're formatted correctly? Well, what we can do for this is use the command line arguments. So why not require that the user tell me what file we're talking about? So I'm going to go back to, I'm going to make my user give me that file name. And then everything else is all of this junk. So I'm going to, I don't know where that goes. Okay, now I can, yeah, it's all of that junk. Nope. Yeah, no. Tabbed. Okay, I see what I did. So it's starting to get kind of nested up a lot. Let me fold a little bit. I can fold the while loop. Yeah, that's a lot less to look at. Okay, so now what I'm trying to do is get at the situation where I want the user to give the file name of the meal with its names, categories, quantities to be processed in by specifying which meal they want at the command line. So I'm going to use command line arguments for this, and then I can get rid of all this junk. So I'm going to check to see if I get exactly 2 arguments. If I don't, then I'm going to do file name. So now what I'm going to do is I'm going to assume that argument is the file, and I'm going to attempt to open it in a file stream, but I still need to check if it fails because they might not have put the right file name in. So I will tell them of this. So now I have kind of 2 error messages. I have the initial, you got to give me a file name message. And I also have, well, you gave me a file name, but it might be to a file that I can't open for reading. And everything else can stay the same. So let's run it. Since I changed the code. Something's wrong. Okay, there we go. Maybe I just lost the usage message in all the mix. Okay, so if I run it with no arguments, then I get the usage message. Hey, you got to give me a file name. If I run it with a non-existent file like lunch.txt, it's going to tell me, well, you gave me a file name, but I can't open it. So that's the end of that. And then if I give it a good file like dinner.txt, it works. And if I give it a good file like test.txt, it should also work, which it does. So this is all of the stuff that's kind of being referenced for you in the lab as I updated it this morning. All of those tests I'm going to do on your code in lab. I'm going to run it. I'm going to click run with no arguments, and I expect to see a usage message. Then I'm going to run it with a non-existent file and expect to see a failed message. And then I'm going to run it with the 2 input files. Thank you, Magenta, for pointing that out, that I hadn't put it in the notes, but I am going to do that. I'm going to run it against the drinks file and the fruits file. And as long as they're formatted the same, then your program should be able to handle them, and I will see their data having been processed in. Okay, so that's the example. Let me grab it. Oh, let's do one more thing, which would be kind of cool. No, I don't need to do that. We just need to, I'll just put a link to this REPL. That'll save me some trouble. And it'll have the sample files in it too. So I'll just put a link to the REPL into the lecture today. Okay, I think that's mostly it. Let's look at the lab. Wait. So thank you, Magenta in chat. So I added that you want both fruits and txt so that your code can be tested against 2 different input files. But let's go inspect them and see if they are formatted the same. So drinks.txt. So notice that your input for the lab is different. It's got 2 fields, not 3, and it's using a colon as a separator, not a comma. Let's make sure that fruits is the same. 2 fields, a name and probably a quantity, and then also a colon. So these 2 files should both work in your code because they're formatted the same with the same kind of information in the same place. Let's see what the program wants you to do with that. It has created a struct, very similar to what we just did. So your job is to open the file, read all the lines in the file, parse all the lines in the file, and populate items. There's only 6 things in here. So usage message, error, can't open the file message, probably. So this one is argc, argv stuff, argc, argv stuff, argc, argv stuff. Then we parse the line. We populate the data fields in an item instance, and then we pass the item to this pre-written print function. So the way I will know if you did it right is your program will spit out a whole bunch of items using my function at the end. Right, so if we look back at my sample, you'll have something like this instead of that other thing. So I'll put that in the REPL as well so that you can see it. So I actually did kind of a slightly harder example than what you'll encounter in the lab. So you don't ask the user, Magenta, no. So Magenta asked, do we ask the user? No, you do exactly what I just did. Exactly what I just did. You run it with no arguments by clicking run. You run it with a non-existent file on the command line, like I just did, which should get a fail message. You run it with an existent file, which should get output. You run it with a different existent file, and you should get output. That's also on the lab assignment itself. If you go down to experimenting testing, I wrote that. So compile the program by testing, run. Then in the REPL console, do these things. Run it with just main. Why can't I highlight that? I don't know. Should display the usage message. Main with a non-existent file should display an unable to open message. Main with the fruits file should display the formatted parsed contents of fruits. Main with the drinks file should output the formatted parsed contents of drinks. Parsed and, I will say. So everything that I just did, it's the same with less data fields and a different separator. So anyway, there's reminders in here, and also there'll be a link to the sample. So yeah, I don't think anyone will get lost on it, but you can always Canvas inbox, office hours, Piazza if you get hung up on anything. But you won't be asking the user for the file name. You will be telling them when they should have provided it with a usage message, and you will be telling them when they gave you a bad file name with an error message. But other than that, they need to supply the file name on the command line for themselves. Okay, that's all I got. I'll wait a second or two for questions, but we'll close out just a bit early today. Thank you, Magenta. I appreciate it. You have a good week as well. All right, see everybody on Monday next week. I probably will not have had time to grade the projects by the time I see you next week, but I will be scrambling as fast as I can to get them graded on Monday or Tuesday. Thank you, Edcast. You have a great week as well. See everybody next week.